So in the previous class, we were talking about the operational amplifier, and we said that for operational amplifier, we have different applications for the operational amplifier. One of them is to use the operational amplifier as an inverting device. One of them is to gain the voltage by using non-inverting operational amplifier. If I would like to use it as a summing operational amplifier, I can. I can use the operational amplifier for many purposes, like what I showed you. And today I would like to solve some problems related to the simple operational amplifier that we started talking about it. Before I start talking about some problems, I would like to show you some different configurations of the operational amplifier. I can use two different operational amplifiers in series by creating a cascade operational amplifiers. I can use two different operational amplifiers, not in parallel actually, but I can connect them in a specific way to have two different outputs. I'll show you that right now. So we would like to talk about some different operational amplifiers configurations. From these configurations, number one, we are calling it buffer or voltage follower amplifier. So for voltage follower amplifier, the equivalent circuit for that operational amplifier is something like that. This is V out, and this is V input, and this is the feedback. It's shorted. So for this operational amplifier, I'm not using any resistor. And based on that configuration for the operational amplifier, I can say that IN is equal to IP is equal to 0. If you try to look to this circuit, VP is the voltage from that point to that point. Am I right? VP is this voltage. So what is the relation between VP and VN? They are equal. So this guy, if I change the color, I can say that this guy is VP and the voltage for that point is VN. So I can say VP is equal to VN, and I can say that VN is equal to VP. Now, if this voltage is Vn, which is the voltage from that point to the ground, which is the voltage from that point to this, the voltage from that to this, the voltage from that to this, and so on. So what is the relation between V output and V input? And sorry, Vn. They are equal. So I can say V output is equal to Vn. So based on that simple definition, since Vp is equal to Vn and Vn is equal to Vp and V output is equal to Vn, I can say Vn is equal to V out. That's why we are calling this guy as voltage follower or buffer operational amplifier. I'm using it only for giving the same output of the voltage. Yes.
Yeah. So what kind of practical use would that have?
I'm using this guy simply for like a connection between the source and my circuit. That's it, because it's voltage follower. Now, let us talk about the second configuration for that operational amplifier, something called cascade operational amplifier. For that guy, we are using two different operational amplifiers connected like that. This is negative, this is positive, this is positive, this is negative, and we have here a resistor, and we have here another resistor, which is feedback resistor, and this is the feedback resistor for the second operation amplifier, and we have input here, its resistance is this guy, the input, this is the input voltage, and this is the positive terminal, and this is the positive terminal for the next operation amplifier, and this guy is considered as the output. This is, imagine it is node C, this is, imagine it is node A, it is node, for example, B. And we have an output here, which is the first output from that operational amplifier. I can connect these two operational amplifiers in that way, and I will call that cascade operational amplifier. How to deal with such a problem? To find a relation between the outputs and the input, what I have to do, I will say summation the cat for each node is equal to 0 to deal with these types of operational amplifiers. So I will say summation the cat for that node is equal to 0, summation the cat for that node is equal to 0, summation the cat for that node is equal to 0, and I have to define all IP, all IN, all VP, all VN for that operational amplifier. So if I got something like that in my final exam or my midterm, how to solve such a problem? Solve it like what we did before. Let us deal with this as a problem. Let me put some values and ask you to calculate the output. Imagine, for example, I have input voltage here, for example, 2 millivolts. And I have here 1 kilo ohms. And for this one, imagine I have 5 kilo ohms. And for this guy, imagine I have 20 kilo ohms. And this guy has like 5 kilo. And this guy has, for example, 1 kilo. And this is op-amp 1, and this is op-amp 2. What do you like to do for this circuit? I would like to find the output voltage, and I would like to calculate V1. And also, I would like to calculate the output current for this circuit. So the first thing, I would like to calculate the voltage between these 2 points, and I would like to calculate as well the current output here. So let us imagine we would like to deal with this as a problem, and I would like to calculate VO. So for calculating VO, the first step to deal with that type of operational amplifier, and imagine, for example, I would like to calculate a specific current here. For example, imagine I would like to calculate this current, which is IO. I'm trying to give you any problem related to that circuit. So the first step for solving such a problem is to define VP, VN, IP, IN for each operational amplifier. So this voltage is VP1. This voltage is VP2, right? Imagine I will call VP1 is the positive voltage for the operational amplifier 1, and P2 is the positive voltage for operational amplifier 2. You told me that at the beginning of that part, you told me that VP is equal to VN. So based on that, I can say VP1 equals VN1, and at the same time, VP2 equals VN2. But I couldn't say P1 is equal to P2. I couldn't say that because these are two different operational amplifiers and they are connected to two different locations. So if I assume that this is VP1, where is VN1? VN1 is the voltage from that point to the neutral, which is considered as this voltage. Am I right? So this guy is Vn1. Where is Vn2? Actually, Vn2 is the voltage from that negative terminal, which is considered at this voltage. Am I right? Are you seeing that, guys? So this guy is Vn2. My question right now, what is the value of Vp1? What is the value of Vp1 here in that circuit? It's 0. What is the value of Vp2? Yes, Vp2 also is equal to 0. So because it is the voltage across this wire that doesn't have any resistor. So based on that, I can say the voltage for that node is equal to 0. So Vn1 is equal to 0 and Vn2 is equal to 0. So I can say Vp1 is equal to 0, and based on that, Vn1 is equal to 0. And Vp2 is equal to 0, and based on that, Vn2 is equal to 0. Now, I will define this current, which is Ip1, and this current, which is, this is In1, and this is Ip1. And this guy is In2, and this guy is Ip2. Also, I can say that Ip1 is equal to In1 is equal to 0, and Ip2 is equal to In2 is equal to 0. Now, you would like to calculate VO, so you have to put VO in a certain equation. I will say summation the current for that node is equal to 0. This is the node that I have. I will say summation the current for that node is equal to 0. This is another node that I have. It is function of IO, so I can find IO from that node. I will say summation the current for that node is equal to 0 as well. Let me write all of these equations. Summation the current for the nodes is equal to 0. So if I said summation I is equal to 0 for node A. For node A, I have this current, which is the summation of this and this, right? So if you try to find summation the current for that node is equal to 0, I can say this current, which is VA, which is 0, because VA is equal to Vn1, minus this voltage, which is 2 millivolt, divided by 1 kilo. So if you try to substitute or write that, I can say Vn1 minus 2 milli divided by 1 kilo plus this current is 0, and this current is the summation of this guy and this guy. So this current is Vn1 minus V1 divided by 5 kilo. So Vn1 minus V1 divided by 5 kilo plus this current, which is Vn1 minus this voltage, which is VO, divided by the resistance, which is 20 kilo. This is plus In1, which is equal to 0. Don't forget that this guy is 0. Don't forget that Vn1 is 0. And don't forget that I have this equation, which is function of VO and V1. So I have to find another equation, which is function of VO and V1 to be able to solve them for finding the value of V1. So I'm going to say, for example, summation the current for node B is equal to 0. I have this current, I have this current, I have this current. So I will say summation I is equal to 0 for node B. So this current is Vn2 minus V1 divided by 1 kilo plus this current, which is Vn2 minus VO divided by 5 kilo plus this current, which is IN2 equals 0. You told me that this guy is 0. You told me that this guy is 0. You told me that this guy is 0. Then I have two equations in two unknowns, which are VO and V1. I can solve these two equations for finding the value of V1 and VO. If you try it, you will find that V1 is equal to 40 millivolt, and you will find that VO is equal to negative 0.2 volt. Now, I have already calculated what you asked me about, which is VO, but I didn't calculate the value of IO. What is IO? Which is this current. I would like to calculate the value of IO. How to calculate it, guys? I will say summation the current for that node is equal to 0. Am I right? So this current is equal to this current and this current. Is it right? So I can say IO is equal to this voltage minus this voltage divided by 5. This voltage is V1 minus 0 divided by 5 kilo plus V1 minus 0 divided by 1 kilo. So based on that, from node C, I can say IO is equal to V1 minus V in 1 plus, this is 5,000, plus V1 minus V in 2 divided by 1 kilo. Is it 1 kilo? Yes. So I have 1 kilo and 5 kilo. You told me that this guy is 0 and this guy is 0. I can substitute by V1. You will find that IO is equal to 48 microampere. This is if you would like to calculate IO, and this is what he asked me about. So I asked you to calculate VO and IO. If I asked you to calculate the overall gain, if I asked you to calculate the overall gain, what is the overall gain, guys? Is it V output divided by V1 or V output divided by this voltage? Divided by 2 milli, because this is the overall gain. I'm feeding by this and I'm getting this. So if you would like to find the overall gain, I can say this guy is equal to V out. If I asked you, divided by 2 milli. If you calculated this, it is negative 100 without any unit, because it is voltage over voltage. I got negative sign here. Why? If you try to go to the circuit again, this guy is inverting or non-inverting? It's inverting, and this guy is. That's why I'm expecting that I will have negative gain, not positive gain. Any question for this simple example? Yes.
If we want to calculate the gain by the op-amp 2, we will divide VO by V1.
You will find this voltage first and divide both of them. Yeah. Any question, guys? Let us see another problem, which is dealing with similar story. Here he is telling me two ideal operational amplifiers in the circuit are shown below. Calculate VO1 and VO2 and the power delivered by the operational amplifiers. They give me these two circuits. This one and he told me that this is 20 volts. This is negative 20. He said this is positive and this is negative. This guy is 15 volts. He said we have this guy, which is 500 ohms. And this guy is connected here to that. This is node. And then this guy is 2 kilo. And this guy is 5 kilo. And we have another operational amplifier here. This guy is positive. This guy is negative. This is 10 volts. And this is connected here. This guy is 400 ohms. And this is connected to this. This guy is connected to this. And we have 1 kilo ohms. And this is the common point. He told me that this voltage is V out 1 and this voltage is V out 2. And he said this is 20 volts and this is negative 20 volts. He gave me these two operational amplifiers and they said these two are identical. Operational amplifiers, they are ideal. He said they are ideal operational amplifiers, not identical. And he asked me to calculate V output 1 and V output 2. So, how to solve such a problem? Solving such a problem, what I have to do is I have to define VP, VN for each one. I have to define IP, IN for each one. And then I will say IP is equal to IN is equal to 0, and VP is equal to VN is equal to 0 as well. VP is equal to VN, it's not equal to 0, and IP is equal to IN is equal to 0. So I have to define I and V, P and N for each operational amplifier. Let us call, for example, let us call, for example, the first operational amplifier, which is this guy. Let us call this guy 1. And let us call this guy 2. Or vice versa, doesn't matter. This is only name. Let us call the first one M and the second one H. Okay, anything. Then I will define the voltage for each. So I will change the color to make it more easier for you. So this voltage is VP. Are you seeing that color? Are you seeing that color, guys? This guy is VP1, and this guy is VN1, and this guy is VP2, and this guy is VN2. By the way, the current here is IP1, the current here is IN1, and the current here is IP2, and the current here is IN2. Now, what is VP1? Yes, VP1 is equal to 15 volt. He defined the voltage for that node is 15. This is not open circuit. The voltage from that guy to that point is 15. It's not opened. The voltage from that point to that point is 10. It's not open circuit. But this is the way of drawing the circuit. This is the source. Are you seeing that, guys? So based on that configuration, I can say VP1 is equal to 15 and VP2 is equal to 10. So I will write that here. I will write VP1 is equal to VN1 and VP1 is equal to 15. So VN1 is equal to 15 volts. And VP2 is equal to VN2 and VP2 is equal to 10 volt. Then I can say VN2 is equal to 10 volt. And don't forget that IP1 is equal to IN1 is equal to 0 and IP2 is equal to IN2 is equal to 0. Now, let us see, this guy is VN1. What is the voltage for this node? It's VN1 as well, because there is no resistor connected here or anything. It is the same point, which means if I assume that this is, for example, node A, I can say the voltage for node A is equal to VN1. So I can say VA is equal to VN1 is equal to 15 volts. If I assumed, for example, this node is node B, so the voltage for node B is equal to VN2, which is 10. So I can say based on that, VB is equal to VN2, which is equal to 10 volts. Okay, what do you want? I forgot. He asked me about calculating VO1 and VO2. Calculate this voltage and calculate this voltage. So what should I do? I will say summation the current for the node is equal to 0. Where are my nodes? I have this one, right? And I have this one. So I would say summation the current for node A is equal to 0. Summation the current for node B is equal to 0. To put VO1 in my equation and VO2 and find them. So I will say summation V is equal to 0 for node A. For node A, I have this current, I have this current, I have this current, I have this current. This current is IN1. This current is VA minus VO1 divided by 500 plus. This current is VA minus VO2 divided by 2 kilo plus this current is VA minus VB divided by 5 kilo. This guy equals 0, and this is equation number 1. Any question for equation number 1, guys? Any question? Yes. So, I wrote summation I. I said summation V, but probably I wrote it I. I'm sorry. Thank you, my friend. This is why it is not erasing that. Okay, so draw erase this guy. I would like yes. Thank you. Summation I. It's not voltage. I said summation I, but I wrote V. I'm sorry. So Summation I is equal to 0. I wrote the first equation. Summation I is equal to 0. I will write the second equation for node B. So summation I is equal to 0 for node B. I will have this current, this current, this current, this current. This current is I into plus this current is VB minus VO2 divided by 400 plus this current is VB minus 0 divided by 1 kilo plus this current is VB minus VA divided by 5 kilo is equal to 0. Now, this guy is 0 and this guy is 0. I know everything about VA and VB, but I don't know V output 1 and V output 2. Based on these equations, I can find V output 1 and V output 2. So from this equation, I can calculate V output 2 and then substitute in this equation for calculating V output 1. So if you try to do that, you will find that V output 1 is equal to 15.85 volt and V output 2 is equal to 13.6 volt. He asked me also about the output power going from this guy and the output power going from this guy. What is the power equal to? P is equal to what? V times I. So for finding the power, what should I do? I have to calculate the current for the operational amplifier. So for calculating the current for this operational amplifier, this current is equal to what? It is equal to this, right? So this current is considered as IO1. It is equal to this current. Am I right? So I can say IO1 is equal to VO1 minus VA divided by 500. So IO1 equals VO1 minus VA divided by 500. So this guy will be equal to, if you try to calculate it, it is 17.5 milliampere. What about IO2? IO2 is this current. It is equal to what? It is equal to this plus this, right? So this current is VO2 minus VA divided by 2000 plus this current is VO2 minus VB divided by 400. So this guy should be equal to 8.3 milliamps. Last step before leaving, I will calculate PO1, which is VO1 times IO1, and I will calculate PO2, which is VO2 times IO2. This guy will be equal to 11.2.9 milliwatts, and this guy will be equal to 26.9 milliwatts. Like what you are seeing here for VO1 and VO2, they are between 20 and negative 20, so I will accept them, and then based on that, I will calculate IO1 and IO2. After calculating IO1 and IO2, I substituted in the equation of the power to calculate PO1 and PO2. I will stop here, and next class I will talk about the practical operational amplifier. If you have any question, please let me know. So do you have any question, guys?